Good afternoon, dear students. So in the last class, we were discussing the MCQs and fill in the blanks on the chapter acid, bases, and salts. So we have completed the fill in the blanks and MCQs, that is multiple choice questions. Okay. So today we are going to see some of the very short type of question answers and short questions and long type of question answers. Okay. So I think, yes, so these were the questions which we have discussed in our previous class. Okay, so already we have discussed the synopsis also, yes, about acid, bases, and salts. Okay, so in these sessions, in these last one and last session and today's session, we are solving the questions. Okay, we are solving the some competitive type of questions. Okay, fine. So these were the questions which we have already discussed. Okay. So yes, we have discussed this fill in the blanks also. Okay. So these are the very short answer type questions. Okay. So okay. So shall we start with this question and answers? So if you want to answer, okay, you can use the chat box. Okay, there you can give your answers. Okay, fine. Okay, so let us start with the question answers. Okay, that is very short answer. So for this very short answers, okay, you have to give to the point. Okay, you should not explain this. You should not explain this. Very short means to like one word or one sentence. Okay, so you should not explain this. It will be for 1 mark. Okay, it will be for 1 mark. Fine. So these are the questions which are for 1 mark and you have to explain in a sentence or in a word. Okay, fine. So let us start with the first question. So which gas is formed when limestone is heated? Is anybody? What is a limestone? Which gas is formed when limestone is heated? Yes, students. What is a limestone? So limestone is your calcium carbonate. Okay, calcium carbonate. Okay, so this is the formula for your limestone. So limestone is nothing but your calcium carbonate. So when your calcium carbonate is heated, okay, when you heat it, what you get? You're going to get a calcium oxide and carbon dioxide gas is released. Okay, carbon dioxide gas is released. Okay, so this calcium oxide is also called as quicklime. Okay, it is also called as what? It is also called as quicklime. Okay, so remember this. So calcium carbonate is the limestone. So when we heat limestone, okay, we are going to get what? We are going to get calcium oxide, which is called as quicklime, and which gas is going to release carbon dioxide. So what should be your answer? Which gas is formed when limestone is heated? So carbon dioxide gas is formed when limestone is heated. Okay, this is your answer. So which gas is formed? Carbon dioxide gas is formed. Okay, fine. So let us go for the next question. Okay, next question. Write name of two natural and two synthetic indicators. Okay, so what do you mean by natural indicators? Natural indicators means they are they are obtained from nature. Okay, they are obtained from nature. And synthetic indicators means what? Synthetic indicators means they are man-made. Okay, they are man-made indicators. So they have asked you two natural indicators and two synthetic indicators. Yes, can you answer it? You can use the chat box. You can use the chat box. Okay. So, two natural indicators. Okay. Natural indicators means what? I said they are obtained through nature. Okay. Natural indicators. And next is synthetic. Synthetic means man-made. Okay, man-made indicators. Okay, fine. So what is the synthetic and natural indicators example? One will be a turmeric. Okay, you can take turmeric. So turmeric is a natural indicator. Okay, so natural indicator, it turns bright red. Okay, turmeric, it turns bright red when you expose it to bases. So bases, when you have a base, it will turn what? It will turn bright red. Okay, it will turn bright red. And yellow, okay, it will turn yellow when it is acidic. Okay, it is acidic in nature. So turmeric. Then another natural indicator, you can take China rose. Okay, another natural indicator is China rose. So China rose, okay, uh, so China rose also is a natural indicator. So it produces red color. Okay, when its petals, they are soaked in water. So it produces, it will be like hibiscus. Okay, China rose, it looks like hibiscus flower. So they have asked you two natural indicators. So just tell turmeric and China rose are the two natural indicators. And synthetic indicators, so what are the synthetic indicators? First one is methyl orange. First one is methyl orange. Second one is phenolphthalein. Okay, second one is phenolphthalein. Okay, phenolphthalein. So these are the two indicators. Okay, these are the two indicators. Got it? Okay, so write name of two natural and two synthetic indicators. Natural indicators are turmeric and China rose. Synthetic indicators are methyl orange and phenolphthalein. The spelling should be correct. Okay, if you write wrong spellings, then your answer will be wrong. So write the spellings properly. Okay, fine. Let us go for the third question. Okay, third question. A gas turns lime water milky. Identify the gas and write the balanced chemical equation for this process. A gas turns lime water milky. Okay, so you have to write the equation for this. Okay, how you're going to write this? So you have to write the gas turns lime water milky, identify the gas, okay, and write the balanced chemical reaction. So gas turns lime water milky, okay, and which is the gas that turns lime water milky? It is carbon dioxide gas. It is the carbon, identify the gas, it is carbon dioxide gas. A gas turns lime water milky. So write the reaction for that. How the gas turns lime water milky? So lime water is your calcium hydroxide. Okay. Lime water is your calcium hydroxide. Okay. This is aqueous state. It reacts with your carbon dioxide gas. It gives you calcium carbonate. Okay. Plus water. Plus water. Okay. So calcium hydroxide plus carbon dioxide giving you calcium carbonate plus water. So which is the gas? So which is the gas which is responsible for this reaction, that is carbon dioxide gas, and you have to write this balanced equation. Okay, so this balanced equation should be written. So calcium hydroxide, okay, that is your lime water. Okay, when you pass carbon dioxide gas through lime water, it terms what it gives you calcium carbonate. It gives you calcium carbonate and water. Okay, and this calcium carbonate, it will form the white precipitate. Okay, it will give you a white precipitate. Fine. So this is the answer. Third one. Okay. Okay. Let us go for the next one. Next question. So to the point you have to write. Okay. Why eating sweets is said to be harmful for teeth? Why eating sweet is said to be harmful for teeth? Why? Because if you eat sweets, okay, it can cause tooth decay. It can cause tooth decay. Okay. Your teeth will get spoiled. Okay. Your teeth will get spoiled. Why? Due to the formation of bacteria. If you don't wash off this, okay. So what will produce in your teeth? bacteria will be there. Okay, bacteria in the mouth, what they will do, they will the whatever the sugar will be there in the mouth, it will okay, it will metabolize those and it will form acid. Okay, and this acid will spoil the your teeth. Okay, denture of the teeth. Okay, then due to plaque formation, okay, due to plaque formation also, what will happen, whatever the sugar is there in your mouth, it will get combined with the saliva. Okay, it will get combined with the saliva and bacteria. Okay, and it will form a plague on your teeth. Okay, what will happen, whatever the enamel is there in your mouth, it will get dissolved. Okay, by this plague, and due to that, cavities will be formed, more cavities will be formed. Okay, so what is the this how to control your teeth to from decay? You have to brush your teeth. Okay, you have to brush your teeth soon after eating anything. Okay, so what is the answer? Why eating sweets is said to be harmful for teeth? Because it causes tooth decay. Because it causes tooth decay. Eating sweets is harmful for teeth because it can cause tooth decay. Okay, it can cause tooth decay. I hope you have got the answer. Okay, let us go for the next one. Fifth one. Fifth question. Okay, fifth question. Write name of two salts belonging to family of sodium salts and chloride salts. So you have to tell two salts. Okay, one belonging to sodium salts. One belonging to sodium salts, another belonging to chloride salts. Okay, another two chloride salts. Write name of two salts belonging to family of sodium salts and chloride salts. Yes. So sodium salts, you can write NaCl, right? Then you can write NaSO4. Okay, so these are the sodium salts. Then similarly, you can have NaCl. So here chloride salts will be potassium. Okay, potassium chloride. Okay, so these are the salts. Okay, so two salts, sodium chloride and your what sodium sulfate, potassium chloride. Okay, so sodium chloride and sodium sulfate, okay, they are the sodium salts, and your potassium you can write NaCl. So your NaCl and potassium chloride also are the chloride salt. Okay, so these are the examples of your sodium salts and chloride salts. Okay, so yes. Next question. Write the name of the chemical produced from common salt. Write name of the chemical produced from common salt. What is a common salt, students? What is a common salt? Common salt is your NaCl. Okay, NaCl is the common salt. So which are the chemicals which are produced from the common salt? First one is NaOH. Okay, NaOH is obtained from your common salt. Second one is, okay, Na2CO3. Anyone you can write. Write name of the chemical produced from common salt. So anyone you can write. And another is sodium hydrogen carbonate. Okay, so anyone you can write. Sodium hydroxide, sodium carbonate, and sodium hydrogen carbonate. So any one of the chemical you can write which is produced from the common salt. That is okay. So from NaCl, so these are the three chemicals which are produced. Okay. Let us go for the next question. Seventh question. Seventh question. Write the name of any natural material that can be used to prepare indicator. Write the name of any natural material that can be used to prepare indicator. So natural indicators, okay, natural indicators, they are produced or they are obtained from the natural sources. Okay, from the natural sources like your turmeric. Okay, so the turmeric is your natural source. From natural turmeric you can okay, you can obtain, you can prepare indicator. Then your red cabbage. Okay, so this is also another. Then your onion. Okay, onion, tomato. Okay, tomato. Okay, beetroots. So these are some of the examples of your natural indicators. Okay, so these are some of the examples of natural indicator. So write the name of any natural material. Okay, so these are the natural material from which you can prepare your natural indicator. So anyone you can write. Okay, anyone. So I've given you many options. You can write any one material from which you can obtain the natural indicator. Okay, let us go for the next one. Okay, eighth question. We have completed 7 questions. Okay, let us go for the eighth question. What is the nature of milk and milk of magnesia as per pH scale? What is the nature of milk and milk of magnesia as per the, okay, so milk, okay, milk, it is what, it has a pH from 6.5 to 6.7. Okay, so this is slightly acidic. So we know that less than 7, whenever you have less than 7, okay, then it is acidic. Okay, less than 7. So the normal milk, okay, obtained from your cow buffaloes, so that is having a pH of 6.5 to 6.7, and this is what, slightly acidic. So this acidity, whatever the acidity is there, it causes the milk to form the curd formation. So because of this acidic pH, milk can be converted into curd. Okay, milk can be converted into curd. Then what is the difference of milk of magnesia? Milk of magnesia. So it has a pH of about 10.5. Okay, it has a pH of about 10.5. So above 7, okay, it is what? It is basic in nature. Okay, it is basic in nature. Fine. So milk of magnesia, it is what? It is a magnesium compound. Okay, milk of magnesia, it is a magnesium compound. Okay, it is used as an antacid. Okay, if in your body there is more amount of acid, so you can take this antacid. It is like a anti-tablet. Okay, it is like a tablet to cure your acidity, antacid. Okay, so what is the difference between milk and milk of magnesia? Milk has a pH of 6.5 to 6.7, which is slightly acidic. Because of this acidic property, the milk can be converted into curd. Okay, it can have that curd formation. Okay, and what is milk of magnesia? Milk of magnesia, it is a substance obtained from magnesium. Okay, it consists of magnesium, okay, compound, and it has a pH of 10.5, which is basic in nature. So this milk of magnesia, okay, it is used in the okay, it is used as an antacid. Okay, antacid, so that your whatever, if in the body more acid is produced, so it can be neutralized. Okay, fine, let us go for the next one. What are the products of reaction of dilute acid and active metal? So what they have asked, when an active metal, when you have a active metal, when active metal will react with dilute acid. So they have asked what is the product obtained. So can we take an example of a metal like Na, okay, sodium, when it reacts with a gas, okay, like 2HCl. Okay, what it will produce? It will produce, what it will produce? 2NaCl plus H2 gas is liberated. So this is the equation. So what are the products of reaction of dilute acid and an active product? It is a salt and gas. Okay, what is obtained? Salt and gas is obtained. NaCl is what? It is a salt. And what is H2? It is a gas. So when active metal, okay, is reacted with dilute acid, what are the products obtained? One is a salt, another is a hydrogen gas. Okay, another is the hydrogen gas. Understood? So you can write, so which are the products obtained? It is a salt and hydrogen gas. Okay, fine. Let us go for the next one. Why does solution of an acid in water conduct electricity? Why does solution of an acid in water conduct electricity? Acid. Okay, suppose I have HCl and I have added in a water. Okay, so when you have a container, now this container consists of both acid as well as the water. So when you add acid in water, it will split. It will split into what? It will split into H plus ions and Cl minus, H plus ions and OH minus. So why does the solution of an acid in water conduct electricity? Due to the presence of hydrogen ions, due to the presence of H plus ions. Okay. So due to the presence of ions, okay, it causes to conduct the electricity. So remember that. Okay. So why? Due to the presence of H plus ions. Okay, fine. Let us go for the next one. Why does curd and sour substances not to be kept in brass and copper vessels? Why should we not store the curd and any sour substances in the brass and copper vessels? Why? So now curd, okay, curd because of the slightly pH, slightly acidic pH, okay, if you put it in the brass, okay, or your copper vessel, okay, so as the curd is having slightly acidic pH, what it will do, whatever the this is there, the acid is present in the curd, it will react with the metal. Okay, it will react with the vessels. Okay, and it can cause corrosion. Okay, it can cause corrosion or it can cause food poisoning. Okay, it can cause food poisoning. So because of this reason, you should not keep the curds and any sour substances in the brass and copper vessels. Okay, because what it will do, it will spoil the vessel. Okay, it will spoil the vessels. Okay, so why should curd and sour substances should not be kept in brass and copper vessels? Because of this following reason. It can, because in the curd acid is produced, acid is there, so that acid will react with the vessels of the copper and your brass, and corrosion, food poisoning can occur. Okay, fine. Next question. Okay, so next is the short answer type question. So little explanation is required. Okay, so little explanation is required. So let us start with the first one. Define alkali. Write few characteristics of a base. Define alkali and write few characteristics of base. Define alkali. Write few characteristics of base. How you are going to answer this, students? What is an alkali? First question is define alkali. So you can see this question is divided into two. Okay. Define alkali and you need to write the characteristics. So what is an alkali? The bases which are soluble in water are called alkali. Okay. Bases soluble in water are called alkali. So this is my first answer. Okay, this is my first answer. Next question. Write few characteristics. Okay, you need to write the characteristics of an base. Characteristics of base. How are you going to answer? Bases are first. when you start with the taste, okay, they taste bitter. Bases, they taste bitter. Okay, they are soapy to touch. Soapy to touch. Then they are having pH greater than 7. Greater than 7. Okay. Then when bases react with acids, okay, they form salt and water. So characteristics, one more characteristics we can write. Bases conduct electricity. Okay, they conduct electricity. Okay, when dissolved in water. When dissolved in water. Okay, and so these are 1, 2, 3, 4, 5. Yes, 5 are enough. So what is alkali? Bases soluble in water are called as alkali. What are the characteristics of base? They taste bitter, they are soapy to touch, their pH is greater than 7. When bases react with acid, they give you salt and water. Bases conduct electricity when dissolved in water. Okay, fine. Next question. Why does dry HCl gas do not change the color of the dry litmus paper? Why does dry HCl gas do not change the color of the dry litmus paper? Dry HCl gas, okay, dry HCl gas, okay, it is not able to dissociate. Okay, now if you take a regular HCl gas, if HCl gas, it will split into H plus and Cl minus ion, but whenever dry HCl is there, it will not get dissociated. Okay, it will not get dissociated and it will not give you hydrogen ions. Okay, now if you have a acids, regular acid, now HCl, so what it will do, it will associate, it will dissociate. Okay, and what will happen, the aqueous paper will get wet. But if dry HCl is there, how, if the HCl is it is not having any water content, right? So because of that, the litmus will not, paper will not get wet, and because of that, the color will not change of the litmus paper. So dry litmus paper, dry HCl gas do not change the color of the dry litmus paper, because HCl gas do not dissociate to give you H plus ions. Okay, and because HCl is it is not having any aqueous content, so the litmus paper will not get wet. Okay, so this is the reason why litmus paper will not get wet. Okay, next question. While diluting an acid, why it is recommended that the acid should be added to water and not water to acid? Now, suppose I have a 10 ml acid. Okay, I have a 10 ml acid and I have a 50 ml water. Okay, so it is said that acid should be added to water and not water to the acid. Why? What is the reason? What is the reason? Suppose I have 50 ml, not 10 ml. We can take more also. Okay, I can take 50 ml also. Okay, 50 ml acid. Okay, is added. So they say acid to be added in water and not water to acid. So this should not be done. This should be done. Why? What is the reason? Because when you are adding acid to water to an acid, if you do this change, okay, if you do like this as water to acid, okay, what will happen? This reaction is highly exothermic. This is highly exothermic. Okay, so it will means what? It will release more amount of heat. It will release more amount of heat. Okay, so because of this reason, okay, so water should not be added to acid, but you should add acid to water. Why? If you add water to acid, this reaction is highly exothermic. Okay, exothermic means what? It releases more amount of heat. Understood? So whenever you are diluting any acid, you should add acid to water and not water to acid. Understood? Okay. Why? When you add water to acid, it is highly exothermic reaction and it releases more amount of heat. Okay. Next question. How does acid rain harm aquatic life? How does acid rain harm aquatic life? Aquatic life means what? In the ponds, lakes, seas, okay, fish, okay, and other aquatic lives are present. So they are asking, how does this acid rain, okay, it will harm the aquatic life. So what it will do? It will harm, okay, acid rain, it will harm or kill the individual fish, okay, and it will, what it will do? It will reduce their population. It will reduce their population, okay, and what will happen? Slowly, slowly, it will eliminate the fish species from the water body. And what will happen? In turn, their biodiversity will be decreased. Okay, their biodiversity will be decreased. Okay, so whenever an acid rain, what it will do? Whenever it falls, acid rain. Okay, when rain combines with the SO2 gas, okay, sulfides or oxides of sulfur. So acid rain is produced. This so acid rain, when it falls to the earth, it will travel to the soils. Okay, and what will happen? Aluminium is released from the soils into the lakes, and it what will happen? What will happen to, because of that, the water will get shredded everywhere. Okay, so in turn it will harm the aquatic substance. Okay, aquatic, your this, it will become acidic. Whatever the water this is there, it will become acidic in nature, and it will reduce their population, and in turn their biodiversity will be decreased. Okay. Next question. What is acidity in human? What are its remedies? What is acidity in human? What are its remedies? How you are going to say? We say sometimes there is acidity in our body, right? How do you say we got acidity? Yes, yes. How? What is acidity in humans? What do you mean by acidity? When in the body, okay, when in the body more amount of acid is produced. Okay, so in your stomach, especially in your stomach, right? So when in your stomach, when too much acid is produced, okay, too much acid is produced, so because of that, it will lead to heartburn. Okay, you when in your stomach too much acid is produced, what will happen? Heartburn. Okay, your heartburn, you feel like you're getting burning sensation. Okay, and some other symptoms will be there. So how does this too much acidity occurs? It is when you eat more spicy food. Okay, when you consume more alcohol. Okay, then some stress. If you have some more stress. Okay, then if you are smoking frequently, okay, so these are some of the acidity, okay, some of the reasons for causing the acidity. Now, what are its remedies? Okay, what are the remedies? So you have to drink cold milk. Okay, so when you have acidity, you can drink cold milk. So cold milk, if you drink cold milk, what will happen? The acidic level in your stomach will get neutralized. Okay, then some other home, these are some home remedies. Okay, you can eat bananas. Okay, you can eat mint leaves, ginger. Okay, you can include this in your diet. Okay, so these are some of the remedies to reduce the acidic level. Okay. Then you can take antacids. Okay, antacid. If you take counter medicines like antacid, okay, antacids, what it will do? It will it will reduce your acidic level. Okay, so these are some of the remedies. Fine. Okay. Next question. How is bleaching powder produced? How is bleaching powder produced? So bleaching powder is produced by passing chlorine gas, okay, over the your dry slate lamp. That is 2 calcium hydroxide, okay, 2 calcium hydroxide. This is your dry slate lamp line, okay, that is your calcium hydroxide, is your calcium hydroxide. So calcium hydroxide, when you pass chlorine gas, when you pass chlorine gas, you are going to get CaOCl2, okay, CaCl2 plus calcium chloride plus water. Okay, so these are the, so this is by this you can, this is so this is a chloralkali process. So from this you can obtain your chlorine. Okay, you can obtain your chlorine. So bleaching powder is produced by reacting the dry slake lime plus chlorine gas, okay, by passing the chlorine gas over the calcium hydroxide, okay, you are going to get the bleaching powder. So this is the bleaching powder, CaOCl twice. Got it? I hope you have noted down. Okay, let us go for the next question. Why sodium hydrogen carbonate is used in making bread or cake? So your sodium hydrogen carbonate, that is your NaHCO3. Okay, sodium hydrogen carbonate. It is also called as baking soda. It is also called as what? Baking soda. It is used in baking. Okay, so why you use it in bread and cake, so that it will much be soft and fluffy. Okay, so after you put baking soda, okay, hydrogen, that is sodium hydrogen carbonate, it will become your this will be batter. Okay, your cake will be more fluffy and soft. Okay, it will be much lighter. It will increase their volume also. Okay, fine. Next question. What do you mean by setting of plaster of Paris? What do you mean by setting of plaster of Paris? So setting of plaster of Paris, okay, it is a process by which it gets hardens into a solid mass. Okay, when you add water, so when you add water, okay, when you add water, what will happen? It will get hardened, okay, into a solid mass. So it is called as settling of plaster of Paris. Okay, it is called as what? Settling of plaster of Paris. So if you put water, it will get solidified. Okay, fine. Why does tooth decays start when the pH of water mouth is lower than 5.5? Why does tooth decay starts when the pH of mouth is lower than 5.5? How you are going to answer this? So if your mouth, okay, in your mouth when your pH, okay, if it falls below 5.5, if it is less than 5.5, what will happen? The acid will be produced. Okay, so in the mouth, due to there will be some bacteria present, so this bacteria will produce the acid. Okay, and what will happen? The mouth will start to corrode your enamel. Okay, it will corrode your enamel and tooth decay will start. So whatever the bacteria is present in the mouth, okay, they produce the acid, okay, by degrading the whatever the sugar or food particles will be left in your mouth, okay. And after that, what will the whatever the enamel is there, okay, your teeth white color, so that will start to it will harm that, and decaying of tooth will start. So this is the answer for that. Okay, so let us see the long type of questions. Okay, long type of questions. So you have to explain a bit here. You have to answer in a brief. First question. Okay. What are indicators? How can you test the presence of acid and bases by using litmus solution, methyl orange, phenolphthalein? What are indicators? First of all, what are indicators? So indicators, they are the compounds, okay, which will change the color when they come in contact with the substances, that is acid or bases. Okay, so these are the compounds. These are the compounds which change color, which change color when when come in contact with acid or bases. Okay, so these are the compounds which comes in contact with acid or bases. Okay, how can you test the presence of acid and bases by using litmus paper? So, so litmus, okay, it is like a purple dye. Okay, it is a solution. It is like a purple dye. So litmus is of two types. Okay, one is the blue litmus or the second one is the red litmus. So if you take a acidic solution, if you have a acidic solution, so it will turn your blue litmus to red. And if you have a basic solution, okay, it will turn your red litmus to blue. So this is the color change. So there are two types of litmus, blue litmus and red litmus. What is a litmus solution? It is like a purple dye. Okay, it is like a purple dye. So if you have a acidic solution, okay, then blue will turn red. And if you have a basic solution, red will turn blue. Then what about methyl orange? What about methyl orange? So let us see for methyl orange. So if you have a methyl orange indicator, okay, methyl orange indicator, okay, so this is orange in color. Okay, it is orange in color. Now if you have acids, okay, this orange color will turn into red. The orange color will turn into red. And if you have a base, okay, it will turn into yellow. Orange color will turn into yellow. So this is the color change. Okay, this is the color change. So next is phenolphthalein. Phenolphthalein indicator. Okay, phenolphthalein indicator. So this is a colorless liquid. Okay, it is a colorless liquid. So if you have a acid, if you have a acid, it will remain colorless. Okay, it will remain colorless. If you have a base, it will turn pink color. Okay, like pink color. Understood? So what are indicators? So these are the compounds which will change color when comes in contact with the acid or bases. So litmus solution, it is like a purple dye. Okay, basically two types of litmus are present, blue litmus and red litmus. So if you have a acidic solution, so that time if you deep blue color litmus, it will turn into red. And if you have a basic solution, okay, if you have a red litmus, it will turn into blue. Methyl orange, it is originally orange in color. If you have a acid solution, okay, if you put methyl orange to it, it will turn into red. If you have a basic solution, if you add methyl orange to it will turn yellow. Phenolphthalein, it is originally colorless liquid. Okay, when you have an acid, it will remain colorless. If you have a base, it will be pink in color. I hope it is clear. Okay, so you have to explain a bit. Fine? Okay. Explain pH scale. Next is explain pH scale. Explain pH scale. How you are going to explain this pH scale? Yes, students. How you are going to pH scale? So pH scale, okay, when you see a pH scale, it will range from 0 to 14. Okay, it will range from 0 to it will range from 0 to 14. Okay. So here basically, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So basically, so 1 to 6. Okay. It is a acidic pH. 1 to 6 is acidic pH. Then 8 to 9 is a alkaline pH. And your 7, okay, and your 7 is neutral, and your 7 is neutral. So this is about your pH. Okay, so pH scales, what it measures how acidic or basic is the substance. Okay, and it will scale from what? It will scale from 0 to 14. So if the pH of 7, it is neutral. Okay, neutral means what? It is nor acidic nor basic. Okay, if the pH is less than 7, it is acidic. Okay, if the pH is greater than 7, then it is basic. Okay, so this is about your pH scale. Okay, so like this, you have to explain about the pH scale. Understood? Okay. Next question. How do you prepare the following salts? Write 2 uses of each. Bleaching powder, plaster of Paris. How do you prepare the following salt? Okay, bleaching powder. So how bleaching powder is produced? We have seen this. When you pass chlorine gas over calcium hydroxide, okay, when you pass, that is over the dry slake lime. Okay, when you pass the chlorine gas over the dry uh, slake lime, okay, you're going to get bleaching powder plus water. Okay, now what are the uses for bleaching powder? First of all, okay, bleaching clothes, for bleaching the clothes, okay, for disinfecting your drinking water. So if there is some any some dirty thing, so any in the water, you put bleaching powder, okay, and it is used as a linen in the textile industries. Okay, bleaching cotton and linen in the textile industries. Okay, so this is about your bleaching powder. Plaster of Paris. Plaster of Paris, how it is prepared? It is prepared by heating gypsum. Okay. So calcium sulfate dot 2H2O. Okay. When you heat it at 373 Kelvin, okay, you are going to get calcium sulfate dot hemihydrate. Okay. That is your plaster of Paris. Okay. Now what are the uses of plaster of Paris? You're using this plaster of Paris in fractured for supporting the fractured bones. Okay, then for casting for ornaments and decorative materials. Okay, then for statues and artificial decorative items. Okay, then sometimes this plaster of Paris is used to fill the gaps in the teeth. Okay, and for use making the blackboard chalks, your plaster of Paris is used. So this are the uh, how is the preparation and what are the uses of these two. Okay, fine. Next question. Write a short note on washing soda. Washing soda. What is washing soda? The chemical formula for this washing soda is Na2CO3. Okay, that is your sodium carbonate. It is sodium carbonate. So washing soda is the chemical compound with the formula Na2CO3, also called as the sodium carbonate. Okay, and it's salts of carbonic acid. Okay. So where washing soda is used, some people they use washing soda in laundry, homemade detergent laundry, okay, and they use for cleaning the hard water, okay, and to soft that is to treat the hard water and to get a softer water, okay. So these are some of the this, okay. So it is decahydrate. So Na2CO3 dot decahydrate, okay. So this is the formula. So it is an inorganic hydrate of sodium carbonate. Okay. So where washing soda it is used for removing the stain, for if there is any this, okay. If in your what is it called, wash basins, okay, some blocks clogs are there, so that time you can put this washing soda, okay. It will clean the unclogged drains, okay. Then to remove any greasy things, okay. Then to clean the outdoor furnitures, to clean the washing machines, okay. Everywhere you are using this washing soda. Okay. Next is, what are the chemical properties of acid and bases? What are the chemical properties of acid and bases? Yes, students, how you are going to answer this? So acids, okay, acids, we know that they change the color of litmus from blue to red. Okay, they convert the methyl orange from orange, okay, to that is orange to yellow. Okay, and when you have phenolphthalein, it will turn pink color. Okay, phenolphthalein to colorless. These acids they conduct electricity. Okay, they are highly corrosive in nature. Okay, then when they react with acids react with your metal, it will release hydrogen gas. Okay, they and when you put acids in water, they will produce H plus ions and they will conduct electricity. Okay. Uh, what is the pH of acid? It is from 0 to 6. These are sour in taste. Okay. So these are some of the properties of acids. Then when we talk about bases, what are the bases? So bases, they change the color of the litmus from red to blue. Okay. They are bitter in taste. Okay. They lose their basicity when you add in water, when you mix it with acids. Then bases react with acid to produce salt and water, and this is called as neutralization reaction. They conduct electricity. These are soapy to touch. They are soapy to touch. Okay, and when you put bases in water, they produce alkali. Okay. What is the pH of this base? It is from 8 to 14. Okay. When as bases react with metal, they produce hydrogen gas. Fine. So these are some of the properties of bases also. So like this, you can write acid and bases properties. Okay. So these were some of the questions. So in the last class, we have discussed MCQs and fill in blanks, and today's class we have finished the short type question, very short type question, and long type of question. Any doubts up to here? Yes. Okay. So I hope the session is clear for you. All the questions, all the answers are clear. Okay. I hope there are no doubts. Okay. Fine. So by this, I shall end this session here. Okay. I hope today's session is useful for you. Please go through the last session also where we have solved the MCQs and fill in the blanks. I hope you will like this session. So thank you, dear students. We'll end this session here. We'll meet in the next class.